2.5 Admins, episode 81. I'm Joe.
I'm Jim.
And I'm Allan.
And here we are again. And before we get started, your customary blog post plug, Allan, is NFS sharing with ZFS.
Yep, so it just walks through how to configure NFS sharing directly in ZFS. And it gives you the NFS ACLs, and just a great way to manage all your sharing with the nice interface that ZFS provides instead of having to do it manually in your OS-specific way.
Right, well, link in the show notes as usual. I came across an article on computerweekly.com about ransomware, and the headline is, Backups no longer effective for stopping ransomware attacks. This is something that we've talked about before, but it turns out that actually having good backups is something that is more common these days, and so the bad actors that are doing the attacks are finding other ways to get paid.
Well, really what they're talking about is the growth of double extortion or triple extortion. So in addition to extorting you to pay to get the decryptor to get your files back, it's also, and pay more, otherwise we're going to leak your stolen data to either extort your customers or just sell it on the dark web or just go around and informing your customers that we've hacked your shit and ruining your reputation. And so by doing these, we're going to steal your data and charge you to make us throw it away, or we're going to, extort you and your customers, and going multiple levels deep on that.
Except, unsurprisingly, if you pay the Dane Guild, you're never rid of the Dane.
Yeah.
You can pay them to supposedly delete your data all you like, but they're most likely going to leak it anyway. So don't do that. Keep your wallet in your pocket. Deal with it.
Yeah.
Literally, the only thing you accomplish by paying the people who exfilled your data and are threatening to leak it, if you pay them, the only thing you're accomplishing is financing them to keep doing what they're doing, incentivizing them and making it possible for them to do it and do more of it. You're not saving yourself because, again, the odds are very good that despite you giving them money, they're going to dump your data anyway. In many cases, they may already have before they ever asked you for the money.
The point of this is that a backup doesn't help you if they've stolen your data. The backup is still going to solve the crypto part of the ransomware, your files getting encrypted, but a backup doesn't help you if somebody steals a copy of your data, because all it is an extra backup that you don't control. So I'm a little dubious about the headline. Like, yes, backups don't stop ransomware, but they never stopped ransomware. They just let you recover your data that got encrypted without having to pay. Nobody ever thought backups would stop you if somebody stole your data, right?
Right. Now, the big thing here is that, as always, even when the primary goal of the ransomware attackers was simply to encrypt your stuff and then try to sell you a key, one of the better mitigation strategies is to limit the access that any individual user has to your data within your organization. Overwhelmingly, it's because somebody clicked the shiny link in an email or, went to a dodgy website and got compromised that way. It's an individual employee that did something dull, and then an automated tool comes in and busily tries to get at everything that it can touch, whether it's to encrypt it or whether it's to exfiltrate it. Now, if that user has access to literally everything in your entire organization because you haven't segmented your networks, you haven't limited user access, here, there, and the other, then everything goes out. On the other hand, particularly when you're talking about a larger organization, if individual employees don't have access to anything they don't need to have access to, the scope of the damage that them getting compromised and, letting an attacker in to start exfiltrating data is also greatly limited. Now, if you're talking about an advanced persistent threat, they may get their initial toehold with a user and not actually do anything yet, and spend a significant amount of time laterally pivoting and privilege escalating and basically trying to get access to everything before they actually start doing damage. And that's a much more difficult thing to talk about, but very, very few people are actually going to be facing that kind of an APT scenario. The vast majority of these attacks, they're fully automated, and you don't ever talk to a human until long after the damage is already done. The talking to the human part only comes, if you actually contact them to try to give them money, which, again, don't do that.
Yeah, it's a bit like what we were talking about with Spotify, or what you were talking about, Jim. It's all about cookie cutter, drop-in ransomware in this case. Mm-hmm. They don't want to have to spend the time waiting on your network. They just blast it out all over the internet until they get their payday.
Exactly.
A couple of years ago, my office got hit with one. We had one Windows machine in the corner to do the old Java stuff to control IPMI and get on all the weird VPNs for different providers and so on. and it had its remote desktop open to the internet so people could work from home when they needed to. And there was the RDP vulnerability, which meant somebody was able to just break in and ransomware the machine. Luckily, the only file share it had write access to is the one full of operating system ISOs, and it encrypted a bunch of those, but we just rolled back a snapshot and threw away the Windows machine. But it was really, to Jim's point, and Joe's, like, they weren't targeting our machine specifically. They scanned the entire internet for every machine with this vulnerability and infected it with the same ransomware. But because we partitioned things and they only had write access to one share that only contained operating system installer ISOs, it was easy for us to just restore a snapshot from a couple hours before and no problems. But this kind of survey that this article is based on really proves Jim's point as well. 18% of victims who paid had their data leaked anyway. And then a bunch more who refused to pay ended up having, their customers extorted, where it's like, company A gets hacked and customer B is a customer of theirs, and they would go and try to extort customer B. It's like, pay us or we're going to leak all this data we stole from company A about you. And they also found that 35% of people who paid to get decryption keys were left hanging and never actually got a decryption key.
Shock.
So yes, never pay the ransom.
The most important thing is going to be access segmentation. Because again, the vast majority of this, it's an automated tool. It will grab everything it can touch, but it's not really going to try to escalate its privileges or pivot. It's just going to grab everything it can right then in a very brain dead sort of way. The other thing is, it becomes a good idea to keep an eye on what your network traffic levels look like. If your upload to the internet all of a sudden shoots up to completely saturated and stays that way for 10 minutes, an hour, whatever, that's a pretty bad sign. And if you're actually set up to monitor that and alert on that and go look at it and figure out where all that traffic is coming from, that can help you interrupt such an attack before it gets done. And the good thing is that, most organizations that I deal with, they're a lot heavier on locally stored data than they are on, internet pipe. It takes quite some time to get much of that data actually exfiltrated out to the internet. So if you can interrupt it within, the first half an hour or so, you can mitigate the vast majority of the potential damage.
But one thing that you two haven't mentioned is education, is educating the staff to not click the shiny link. Is that just pointless?
It's not pointless, but it's at best putting on a bulletproof vest before you wade into a firefight. The key word there being vest. You can still get shot in the head, the arm, the leg, the foot, the hand. There's plenty of places to get hit, or somebody shoots you with a rifle, not a handgun, and we're going way too deep into firearms here. But the whole point is, if you're going into a firefight, you would want to wear the vest, but you wouldn't just think, I'm invulnerable. Well, educating your users is kind of like that. It is absolutely a useful layer of your defense, but realistically, that's maybe going to cut, I don't know, Allan, what would you say, like maybe 20% of the attacks that come in? If you do a good job?
Like, I think it was, we talk about kind of the Swiss cheese analogy. You want multiple layers of defense, and you get much more value from having a bunch of different layers that are, 80% good than spending all your time getting one of those layers from 80% to 99%.
And user education typically is not going to be good for 80%.
Yeah.
It's going to be good for about 20 typically, and that's if you've done a pretty good job. Humans are just, by and large, not good at this stuff, and you can't make them care. If they don't already, you really can't make them.
Like, if you've ever gotten a reply to an email that went to a big company, you'll see in the quoted part of the big thing is like, this is emails from an external person. Don't click on any of their links. Or where it's mangled all the links to go through their WAF first. Or you get other things of that nature, like the companies that pay a company to come and try to phish all their employees. And like, if you fail it, you end up having to take some training, or you don't get a bonus or something. Or was it some company we talked about middle of last year or so was getting in trouble for the phishing link was telling their employees they were going to, click here to
get a Christmas bonus.
Yeah, you get a Christmas bonus. And it turned out it was actually a phishing scam, like a phishing training scam.
Yeah, which on the one hand, dick move. On the other hand, be aware that's pretty much all it takes. You say, hey, get money if you click the shiny link. Man, a lot of humans are going to click that freaking link.
Yeah, and that's what it depends on to make it work.
Yeah, that was GoDaddy, and we called that episode Free Money, Claim It Now.
Yep.
Well, you know, if there's ever an email claiming to give you free money, it's probably phishing.
And also, probably, some of your users are going to click it. I mean, you're going to need like a Skinner box, just constantly electrocuting people.
I found an article from Andy Lawrence called "Where Did I Put That File? The Time Has Come to Replace File Systems." And he's got this concept called digits. I can't claim to fully understand what he's getting at, and I hope that you two understand better than I do.
It boils down to, he's saying, rather than having a relatively simple hierarchical, basically one-to-one relationship, file system structure, he wants you to put all of your files into a database, is really kind of what it boils down to. So the database means that you can have a many-to-one relationship between labels and files rather than one-to-one. That's kind of like, when you first go to Gmail and you discover that although you're used to putting your email in folders, in the Gmail interface, they named it labels instead. And most people promptly forget that that's a thing, but they renamed it because you can put the same email under more than one label. Whereas if it's a folder, a file goes in a folder and that's it. That's where it is. So his concept with digits is basically, there's a lot of different ways that you might want to refer to any given piece of data. And the idea is that you refer to that file in all those ways in an index. So you can look for your Christmas picture from 2012, or you can look for, pictures of your wife or whatever. And there are a lot of different ways to find any given particular chunk of data. And because they're all properly indexed, the searches should happen very quickly rather than having to just grovel through a file system tree.
He kind of lists some of the issues that he was trying to address. So the shortcomings he found of file systems are that they have a fixed size metadata record for each file and is too big. Reading in and caching the entire file table takes too long and uses too much memory. And the metadata records do not have file classification to determine what is in the file. Like, is this an image or something else? Although to do that, you end up trying to use the MIME type or something. And then do you care that it's a JPEG or a PNG, or is it just images? What granularity do you try to break the files down to? Because if you do too granular, then you're not really grouping files in something meaningful. But if you do too broad, then everything that is remotely an image on my machine is probably still too many files to find the file I'm looking for.
And I got to say, I'm throwing some shade at somebody who says, they plan to replace the file system with their new creation and invention, and yet their understanding of file systems is so shallow that they make a blanket statement like the metadata record does not have a file classification system. Under what file system, on what operating system? Because the answer is not always the same. He talks about file extensions as though they're a universal thing. File extensions are really only important on Windows. They're not particularly important on Linux, and Macs don't understand them at all. Macs only go by the MIME type in the file. So I don't know. I have a feeling like this is a whole lot of hot air coming from somebody with a serious case of Dunning-Kruger.
Yeah.
Wow.
Obviously, there are some file systems where the metadata isn't fixed size, right? ZFS doesn't have pre-allocated inodes or a table somewhere. It's, to some degree, actually has this problem worse because this metadata is all linked into a tree and dynamic, but it means that there's not just, you can't just go read the whole MFT and dig through it. I think in their example that if you had 200 million files on a NTFS file system, the MFT would be 200 gigs and you'd have to read all of that in memory to be able to search everything. In ZFS, it's slightly worse than that. You'd have to walk all of the tree to find the stuff, but ZFS managed to make it a bit faster. And its dynamic thing means that you can actually add that kind of metadata about files to it if you wanted to, although it doesn't really have a way to search for it.
Yeah, but very, very few people are using ZFS on a laptop or a desktop machine.
2/3 of the people on this call are.
Well, yes, but 2/3 of the people are not normal.
Yeah, but no, Joe's point is valid, and honestly, ZFS is pretty orthogonal to this, other than just to point out that, this guy's making these blanket statements that are nowhere near as universal as he thinks they are. Also, his proposed solutions are not that impressive. He talks about the size of the metadata record in popular file systems can range from 256 bytes on ext4, yada, yada, yada. Well, for one thing, inodes can be different sizes depending on how the system's formatted on ext4, which it's hard to tell. Does he not know that, or is he just trying to gloss over things, not to make people's eyes glaze over? I don't know. But his supposed solution just drops the record size to 64 bytes. Well, okay, that's nice, but he's still talking about, for his example with searching 200 million photos, having to have 13 gigs of data in memory for that. Is that better? Sure. Is it, some amazing new thing? No, it really is not.
Well, yeah, like if ext4 needs 256 bytes per file, what fields has he decided to eliminate? Because apparently in that 64 bytes, he's still managing to keep some kind of record of, is it a photo or a document or a video? I'm guessing he can't have very many classifications if he's going to fit it in very few available bytes.
Correct. It's going to have to be very limited. I'm being very negative here, but from the tone of the article, I have a strong suspicion he's done something, quote, clever, unquote, like, hard coding things into only having 256, potential values. Like just...
it does specifically say that it supports 255 different tags. So yeah, he has
what did I tell you?
One 8-byte field there to store 1 byte to just add tags instead of directories, apparently. So that means you could only have 255 directories.
That's going to scale real well with having 200 million different things.
Yeah, and it's like, and then each file has a unique 64-bit number, and that way when you rename it, the same file is still the same number. That's true on, I think, with the inode number on most file systems, and definitely like on ZFS, the object ID doesn't change when you rename a file. So yes, you can refer to everything by its inode number instead, but it turns out humans prefer names to access things.
So what I'm hearing here is that this is not revolutionary. This is not going to change things completely.
Probably not. I'm thinking about some of this, like, if you had something where you actually wanted to use the 64-bit number to access files, you could do that with ZFS. And then if you could just do the tag thing, I wonder if you could build like something like this as a different, instead of a POSIX file system, a digit file system or whatever on ZFS. And that way you would still have a useful file system underneath instead of what this guy's thrown together.
I mean, honestly, a better way to approach that, in my opinion, would be, I don't think it's a good idea what he's trying to do, saying, oh, we're just going to cram everything into an inode, including like this extra stuff, and do it in fewer bytes and everything will be amazing, and you can just keep all your inodes cached. That's not really the best way to go about an index. I mean, all you really need to do is just build a separate indexed database into your file system to apply these tags to. It's a lot more scalable. It's going to be a lot more queryable. You don't have to read in every inode of your entire file system just to be able to do the rapid search that he wants to do, because that data is separate and it's indexed, and you can cache just that, or you can cache inodes, or whatever mixture actually makes your system perform better.
Isn't that what modern file systems do, like on macOS with AFS or whatever it's called?
No, it's more this, they just have a separate tool, like Apple's is called Spotlight, that just keeps a big database of all your files and is able to search based on tags or the types and so on. And so it's not actually in the file system, it's just an extra service. And like KDE has a service for that. It's like Akonadi, isn't it?
I can't remember the name of it.
Most desktop managers on Linux have something that will sit there and crawl over your disk all the time and try to keep this list of it. And I usually turn it off because I don't want it to do that.
Right. And what I was saying would be different from that would be to bake it directly into the file system so that rather than having to crawl the disk looking for this stuff, when you save the file, it's automatically added.
Yeah. Most file systems can do something like extended attributes where you would just put type equals image. Although most of those don't give you an easy way to find all the inodes that are images without walking every inode and seeing if it's an image.
Which is, again, why, I mean, inodes are just not the right place to put this.
Right. But in particular, if you just want to look stuff up by an ID, instead of making up a unique 64-bit number, literally that's what an inode number is. It's a file system unique number for a specific file that will survive being renamed.
Is it possible that Andy here, who thinks he's an iconoclast, actually has shone a light on things that could be improved, but maybe not in the radical way that he's suggesting? Maybe some of the ideas that he's touching on could be adopted by more traditional file systems.
I think the problems that he's talking about are genuine problems. I think that he's greatly overestimating how unique he is in knowing that those problems exist. And I think his proposed solution is kind of batty.
I don't know anything about him, but it just feels like, the type of developer who's learned some new concepts and immediately wants to rebuild it differently, kind of second system syndrome or something, but doesn't actually understand all of it enough to actually be able to, basically his recreation is naive and is going to run into some other problems. I don't tend to have these problems, but I think that's mostly just because I'm so anal about how I organize my files that I don't lose things. Everything has a place and it goes in that place and I can go and find it. Like I don't often have to try to search my whole hard drive for files named with this in the name that are an image. But I imagine, regular people do have these problems.
Well, it's like we talked about recently. Most people don't even understand the concept of a file system. They just look in the app that they are using for the file because they saved it in Word or they saved it in their camera roll.
I wonder if we would blow this guy's mind if we told him about content addressable file systems, where every file its file name is its hash.
Right.
Well, you never know. You might even listen and email in.
Yep.
show@2.5admins.com. Okay, this episode is sponsored by Linode. Go to linode.com/25A to get started with $100 free credit. From their award-winning support offered 24/7, 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. Linode offers great price-to-performance value for all compute instances, including GPUs, as well as block storage, Kubernetes, and more. Linode makes cloud computing fast, simple, and affordable, allowing you to focus on your projects, not your infrastructure. So go to linode.com/25A, create a free account with your Google or GitHub account or your email address, and you'll get $100 in credit. That's linode.com/25A. Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. You can find out more at 2.5admins.com/support. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. And if you want to send in your questions for Jim and Allan or your feedback, show@2.5admins.com is the email. Another perk of being a patron is you get to skip the queue, which is what Kevin has done. And he has asked the question that's been on my lips many times, but you've always ducked out of, Allan. What is the difference between FreeBSD and OpenBSD?
A lot and not all that much.
Didn't you answer that one once about 4 years?
No, it's about 20 years. So yeah, like OpenBSD forked off from NetBSD a couple years after both NetBSD and FreeBSD started from the unencumbered AT&T source code.
Before we get too deep in that, though, I very seriously doubt that's the answer that Kevin was looking for. I suspect he's looking for technical differences.
Yeah, so I think the very first difference, I would say, is the way the projects are run. So OpenBSD has basically a leader, a single person that kind of decides things, and a group of developers work on that. And in FreeBSD, for most of its history, has had an elected core team of like 8 to 10 people that kind of steer the project, but don't exercise as much control as in OpenBSD, which has advantages and disadvantages in both ways, right? OpenBSD is able to focus and go in a specific direction more because it's, one person deciding where they're going. But in the end, both cases, it's volunteer projects. So like nobody's working on stuff they don't want to work on, really. In all open source, it's basically down to people work on what they want to work on, and it kind of goes that way.
Technical differences, Allan. Technical differences.
Yeah. So OpenBSD focuses on security, and like they admit that it's not really a general purpose OS. It's a research vehicle. And they've invented some really interesting stuff around security, including just the concept of sandboxing, like with their version of OpenSSH. They introduced this concept of running as a different user and having separate parts of the daemon, and the privileged one is as constrained as possible and just sends messages over to the unprivileged one that does all the work where, there might be some code that could be more prone to errors. It might have some problem with a buffer overflow or something, making sure that part of the code runs as an unprivileged user and can't cause problems if it breaks. And they then applied that concept to a bunch of different bits.
Sounds like they were talking to Dan Bernstein with that one. That just has strong shades of Qmail wafting off of it, if you remember that mail server.
Similar concept. They built a system called iMessage, or IMSG, as like an API to make it easier to re-implement that same concept in a whole bunch of different daemons rather than kind of the one-off way that Qmail did it. But it's, along the same lines, although it's more separate parts of SSH, whereas Qmail was a bunch of separate daemons that communicated at like over sockets rather than inter-process communication. But kind of the same idea, but just taken further and made more general. They include more stuff in the base operating system. So one of the big differences between all the BSDs and most Linux distros is that the BSDs are a base operating system, and then there's optional third-party packages. But on a default install, you're not going to have any packages installed. It's just the bits that are included in the operating system, and then you add whatever packages you want. So OpenBSD actually includes their own version of X. So they have a fork of X where they've made a bunch of security changes and so on. So it's not the same as the newest X, but it's much more locked down. And I think one of the things it can do is run as a non-root user, which is, I don't think regular Xorg can do that still. And a bunch of different things like that. Whereas FreeBSD is made more as a general server OS, but doesn't actually include a web server by default. Whereas OpenBSD includes a web server and the routing daemons and a bunch of other things by default, meaning that you can, if you have an OpenBSD install CD, you can go and build a server with no internet connection and have all the stuff you would need. FreeBSD, you can kind of do that because there's a mini package repo on the DVD, but it's just less is included in the operating system.
Yeah, I remember you told me that FreeBSD is kind of like just a bunch of Lego. You just make whatever you want out of it.
Yeah.
Whereas it sounds like OpenBSD is more focused and more of a complete experience. It's not just make your own distro.
Well, FreeBSD isn't completely make your own distro, but FreeBSD is much more focused on a server, where OpenBSD can do that, but it's also what comes on the disk is the daily driver the developers use. So it's got a GUI by default, whereas FreeBSD doesn't. And it's just like you can bolt one on the side if you want one. Whereas OpenBSD is the developers use it as a daily driver, which is also true on FreeBSD, but it's just delineated differently as far as, what's part of the operating system is what is just third-party packages that you can install.
Yeah, because like some devs might use Lumina, some might use Plasma KDE, some might use XFCE.
Right. Whereas OpenBSD, they have their own lightweight one that's just built in, and you can install the other ones and use them, but they tend to like what they like and have that built in. But they're basically completely separate operating systems that share some code. A lot of the code that's shared is newer stuff, not the older stuff. A lot of the older stuff has been replaced differently in the two operating systems. The bit they share is just to avoid duplicating effort. Like the Open Crypto framework is very common between them that handles all the stuff for IPsec and things like that. But so if you want a Road Warrior desktop that's super secure, then OpenBSD is a great choice. If you want to run something on a VPS or run a high-performance server or do ZFS, then FreeBSD is a better choice. I've been a FreeBSD user for 25 years, so that's what I like. I've only toyed around with OpenBSD a few times for the podcast, do tutorials and things like that.
Not this podcast, of course. You mean BSD Now?
Yeah, I meant BSD Now.
And you do have some FreeBSD desktop derivatives, like GhostBSD, which is the one that I have tried and think is great.
Yeah, and also the guy that does GhostBSD is great. He comes to our user group meeting.
Oh, right. And they use Mate, which I think is an excellent desktop. It's almost as good as XFCE.
Yeah. I use FreeBSD, so I can just package install any of those I want and then switch between them if I want. But I understand that, especially somebody that was coming from Linux would prefer something that's just all the bits are there. Whereas, I've been kind of in the more of a Lego mode of I'm going to put together the pieces I like in the way I like.
Well, so to be clear, you can do that on GhostBSD as well. You're just not starting out with, frickin' nothing and hoping you can end up with something worthwhile when you're done, which is very much the case on FreeBSD.
Yes. But, when I'm building a server on FreeBSD, it means there's not a whole bunch of stuff I need to strip out because I don't need X on my server or whatever.
Which is why it's a better server operating system than desktop operating system.
Yep.
Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send in your questions or feedback. You can find me on Twitter @Joe Ressington.
I'm @JRSSNet.
And I'm @Allan Jude.
We'll see you next week.